in this video, we're going to take a look and see how to run a hypothesis test about a mean. This problem comes from the section 10.3 and 10.4 homework. So the problem is, it's long been stated that the mean temperature of humans is 98.6 degrees Fahrenheit. However, two researchers currently involved in the subject thought the mean temperature of humans is less than 98.6 degrees. They measured the temperature of 67 healthy adults 1 to 4 times daily for 3 days, obtaining 300 measurements. The sample data resulted in a sample mean of 98.3 degrees, so we have that written down, a sample standard deviation of 0.9. Use the p-value approach to conduct a hypothesis test to judge whether the mean temperature of humans is less than 98.6 degrees Fahrenheit at the 0.01 level of significance. So our mean that we're testing against is the null hypothesis. We're testing against a mean equal to 98.6. Our alternative is, we want to know, is it less than that? So when we write down the information from the problem, we'll need the sample mean, the sample standard deviation, and the sample size. And what we're going to run, because it's a mean, all tests or confidence intervals about a mean are t-tests. So when you get your calculator, we're going to go to Stat, over to Test, and find t-test, which is option number 2. So the t-test that we're going to run, we have statistics. Okay, if we had data, we'd have to type it in a list and we could select that. But in this particular problem, we're given the statistics. That means we're given the mean and standard deviation and we don't have the actual data. So the null hypothesis is 98.3. Then we need the sample mean, which is, the null hypothesis, let's go back up here. That's the 98.6. That's the standard. That's what we're testing our sample against. Alright, the mean is 98.3. Our sample standard deviation was given as 0.9. And the tests, let's see, our sample size is 300. And we want to test and see if the mean temperature is lower. So we pick less than. So we're going to calculate, and what this is going to give us are two items. It's going to give us the test statistic and the p-value. So our test statistic t is equal to negative 5.77, and our p-value, this is 9.71632 times 10 to the negative 9. Okay, so that tells us that E means it's in scientific notation. So the T was equal to the negative 5.77, and the p-value, let me go back to that again. The p-value is 9.71 times 10 to the negative 9. That means take the decimal point and move it back 9 places. So this is how come the p-value is 0. Okay? So how the reasoning works and what this information tells you is, if I draw a picture of the situation, the mean is of the distribution is our null hypothesis, 98.6. What we got on our sample was 98.3. So this says it's 5.77 standard deviations below the mean. It's way down here. That's the t value. That's an actual temperature value of 98.3. The probability to the left of that is basically 0. It's so small that it's 0. So here's the reasoning behind hypothesis tests. So that's really far away to be considered unusual. As a matter of fact, if the temperature really was 98.6, then the probability that you'd get 98.3 average from 300 people is almost 0. It's so small it's almost 0. The level of significance, the 0.01, tells you your cutoff. So the 0.01 is this area right here. There's a t-value that goes with it that's called the critical value. So our critical value is much further away. The probability of unusual, the problem sets it at 0.01. So if you have a probability of p-value less than 0.01, that means it's so unusual that we think that 98.6 is not right anymore. So when it gets so far away, what we do is reject the null hypothesis. And we reject, there's two options. Oh, reject because the p-value is less than the significance level. The p-value is 0, the significance level is 0.01, that's less than, so we reject. And what that means is, even though it doesn't ask, it means that yes, there is evidence that the mean temperature for adults is less than 98.6. So rejecting H, the null hypothesis, yes, it is less than. Okay? I hope that helps with conducting a hypothesis test.